So the Chapter 2 test comes in two parts, the non-graphing calculator part and the graphing calculator part. We will take the non-graphing calculator part first, and these are the things you need to do on that part. Find some key features of a quadratic function, determine the end behavior, roots, terms of a polynomial, find the zeros or roots of a polynomial, and write a polynomial function given the roots. Then on the second part, you have operations with complex numbers, divide polynomial functions, find all roots of a polynomial function, find asymptotes, intercepts, minimums, maximums, and sketch the graph of some rational function, and then some other questions. So let's look at some examples of all of the different things. These numbers here off to the left and the letters off to the left represent the questions that we are going to do in this little review. So starting with this first one, finding all the different parts of this quadratic, which would be the line of symmetry, the vertex, the x-intercepts, and the y-intercepts. So for the line of symmetry, it's x equals the opposite of b over 2a. That is part of the quadratic formula because you'd have plus and minus the square root of b squared minus 4ac to it, and there you have it. But you don't need that part of it in order to find the vertex or the line of symmetry. And so in this case, you would have the opposite of 8 over 2 times 1, so that is negative 4. And so that is your line of symmetry. Right there at a negative 4. Then to find the vertex, you would substitute a negative 4 into the equation, the function. So you'd have a negative 4 squared plus 8 times negative 4 minus 9. And that's 16 minus 32 minus 9. And so then 16 minus 32 is a negative 16 minus 9 is a negative 25. And so down here would be where the vertex is, negative 4, negative 25. Then we'll go to the y-intercept next. That is where you would substitute 0 in to the function, and those two become 0 plus 0 minus 9, so a negative 9 is the y-intercept right there. And since that is the case, we also know that there's a coordinate over here on this side. If we were having to sketch the graph, that is going to be a negative 8, negative 9, because the line of symmetry is equidistant on either side, or the line of symmetry is equidistant from 2 points, one on either side. So you should be able to find that as well. And finally then the x-intercepts. If you can factor it, you should try factoring. If not, then you would turn to the formula which was written up there just a minute ago. So this would become factors of a negative 9 that gets you to a positive 8 when you add them. And that would be x plus 9 and x minus 1. And so then in this case, x is equal to a negative 9, and in that case, x is equal to 1. And so that's right there and right there. And so then your parabola would be like so. And you should be able to find all of that. And this is without your graphing calculator, and none of that should be too difficult, I hope. Then for B, finding the number of roots and all of those good things. So in this case, the number of roots would be the largest exponent. In this case, there's 4. Doesn't mean there has to be 4, but at most there are 4 roots. Because some of them could be duplicate roots, so there may only be 2, or 3, or 1. All right, then the ends of this one, because it is even and that is negative, both ends down. Or both of them go to a negative infinity. If it was something like 3x to the 4th and a bunch of stuff after it, then both ends would be going up. And if it was negative 2x to the 3rd or something odd, then you would have the left end up and the right end down. And if you had something that was positive and odd, then you would have the left end down and the right end up. These two, if you just think about a line and the slope of a line and what it looks like, that will help you with anything that's odd, because mx plus b, x is to the first power, so when m is positive slope, it's this one, and when m is a negative slope, it's that one. That applies to all polynomial functions. And then finally, the number of turns it has would be at most 3. It's 1 less than whatever your largest exponent is. Doesn't necessarily mean it needs to be 3, but so this one could look like this. Since both ends are down, it turns 3 times. It could also be something where it goes like that, and then there. Or maybe it's just up and then flattens and then back over. Something along those lines. Finally then, the number of positive real roots based on how many times the sign changes. Well, it changes from there to there, so that's 1. Changes from there to there, that's 2. Changes from there to there, that's 3. So there can be 3 or 1 positive real roots, because this has to go down by 2, whatever you come up with. If you'd had a 5 here, then it could be 5, 3, or 1. For the negative real roots, you need to put in a negative x, substitute a negative x into the function, so you get negative 2 times the negative x to the 4th plus 8 times the negative x to the 3rd minus 6 times the negative x plus 5. And so a negative x to the 4th is x to the 4th times a negative 2 is a negative 2x to the 4th. Negative x to the 3rd is a negative times 8 is a negative 8x cubed, and a negative times a negative is a positive 6x plus 5. And so now it changes signs, not here, but it does from here to there, and then that's it. So it has 1 negative root. That's real. And that would be everything you possibly would have to do for something like that. Later on, you'll have to figure things out from there. All right, then finding all of the roots. Well, if you look at this, the possible rational roots that this one has would be the factors of 12 over the factors of 1. And the factors of 12 would be plus and minus 1, 2, 3, 4, 6, 12. And the positive roots, just as a point of reference, there are none because it never changes sign. The negative roots, there are none because when you put a negative x into both places, it doesn't change anything. So there's none also. So there's no positive real roots, no negative real roots. That means you have 4 imaginaries, or complex, I should say. And so in order to find them, you're going to have to try to factor, because it never crosses the x-axis. So what are the factors of 12 that get you to 7 when you add them? And that would be 3 and 4. And so you would have x squared plus 3 and x squared plus 4. And then in this case, if you set that equal to 0, you'd have x squared plus 3 equals 0. Subtract 3 to get x squared equals negative 3. Take the square root, and x equals plus and minus the square root of 3i, because the square root of a negative 3 is something with an I, and it's the square root of 3i. Doing this one, same thing, and then you'd have x squared equals negative 4, and the square root of a negative 4 is x equals, and then plus and minus 2i. And then you are done. And there's 2 roots and 4 roots. All right, this next one, if we look at it, possible rational roots would be the factors of 2 over the factors of 1, and that would be plus and minus 1 and 2. Positive roots that it has, none, because it never changes sign again. Negative roots, well, let's see, if you substitute a negative x in there, that's going to become a negative x cubed. If you substitute a negative x into there, that's still going to be plus 5x squared. And then that's going to be minus 6x plus 2. So we have one sign change, two sign changes, three sign changes. So 3 or 1. And there's 3 roots in all. And so now you get the task of doing this synthetically. So then you would get 1, 5, 6, 2. And on the outside, you would not want to try positive 1 or positive 2 because there are no positive roots, so that would be a waste of time. So if you try negative 1, then you would get 1, negative 1, 4, negative 4, 2, negative 2, 0. We found a root. It's a negative 1. Then you have x squared plus 4x plus 2 left. If you can factor it, you would do that. This case you can't because there are no factors of 2 that add up to 4. So therefore you would have to use the formula and say x equals negative 4 plus and minus the square root of 4 squared minus 4 times 1 times 2 all over 2 times 1. And then doing all of the math for this, 4 squared is 16, 4 times 1 times 2 is 8, and 16 minus 8 is 8. And so you have the square root of 8, which you can factor that to 4 times 2, and the square root of 4 is 2, so it's 2 square root of 2. And so therefore, you have a negative 4 plus and minus 2 square root of 2 all over 2. And then because these are all divisible by 2, you can then write a negative 2 plus and minus the square root of 2. And so those are 2 roots as well. And so your roots are negative 1, negative 2 plus the square root of 2, and negative 2 minus the square root of 2. Now remember, if you have something like a negative 4 plus the square root of 2, let's say 7 times the square root of 2 over 2. You cannot divide these two things by 2 and then write negative 2 plus 7 square root of 2. That is not allowed because you have to divide it out of all 3 things. So don't do that. You just have to leave it like this. And you can't divide it out of something that's underneath the square root because they're not the same type of thing. So and one last thing, since these are all the roots, x plus 1 would be a factor, x plus 2 minus the square root of 2 would be a factor, x plus 2 plus the square root of 2 would be a factor. And that's all you do for those. So if you're given the roots, 2 and 4i, and you're supposed to find a polynomial function, since 2 is a root, x minus 2 is a factor. Since 4i is a root, x minus 4i is a factor, and i's must occur in pairs, so x plus 4i also has to be a factor. And you would be done with that if that's all it asks you to do. If it says write it in standard form, then you would have to multiply it all out, and it would be best to multiply those two things together first because then you can get rid of the imaginary part. So x times x is x squared. That is 4ix. There is a negative 4ix, and those two things make 0. And then you have a negative 16i squared, which turns into plus 16. And then you have x minus 2. And now when you distribute this, that's x cubed plus 16x minus 2x squared minus 32. And there's a polynomial function that would have those as roots. Now there's infinite polynomial functions that would have those as roots because you could just take this whole thing and multiply it by, say, 7, and that would still get you those roots. But you don't have to do that part. You just have to come up with one, and that's the easiest one to come up with right there. Or like I said, if it doesn't say anything, you can just write that right there. Then if it gives you another coordinate, If it passes through the point 850, then you have to introduce an a value. And you would have x minus 2, x plus 4i, x minus 4i. And now you would have to substitute that coordinate 50 in. And then a, and then 8 minus 2. And here you don't want to use those. You would want to turn that into the, so you don't have to deal with the imaginary part. It's x squared plus 16. Do that multiplication before you substitute. And so then you would put 8 squared plus 16 here. And so then simplifying this down, this is 6a, and 8 squared is 64 plus 16 is 70, 80. And 6 times 80 is 480a equals 50. And then when you divide by 480, you would get a is equal to 5 over 48. And you can just leave that. And then you would write your function as f of x equals 5 over 48. And then x minus 2, x squared plus 16. Or if you wanted to write those as x plus 4i, x minus 4i, you could. And if it said write it in standard form, well then you would have to multiply it all out, which would be taking this and then multiplying every term by 5 over 48. Okay, moving on to this one, finding this type of a function, horizontal asymptotes. In this case, there is no horizontal asymptote because the numerator degree is bigger than the denominator degree. Had it been the other way around, if this would have been a 2 and that would have been a 3, then you would have a horizontal asymptote at y equals 0. Because when this bottom is bigger, it's 0. If you then change that and say this is 8 and this is 8, well then you have to look at the leading coefficients, which in this case it's 1 and 1, so then your horizontal asymptote would be y equals 1 because you take the leading coefficients when the degree is the same on the top and bottom. Now then, going back to the original. Because this is 3 and that's 2, they differ by 1. And if they differ by 1, and that one's the bigger one, then there's no horizontal asymptote, but that means that there could be a slant. The only way there can be a slant is when they are different. There is a difference of 1, which in this case there is. So we do have a slant asymptote. In order to find it, you need to divide. So you have to take x squared plus 5x plus 2 and divide it into x cubed plus 8x squared plus 6. And so x squared goes into x cubed x times. When you multiply that, you get x cubed plus 5x squared plus 2x. And you probably should move that 6 over there. And then subtracting these things, you get nothing because x cubed minus x cubed is 0. 8 minus 5 is 3x squared. And then negative 2x plus 6. Because you're subtracting, and 0 minus 2 is a negative 2. Then when you take x squared and go into 3x squared, you would put plus 3 here. Multiplying that out, that's 3x squared plus 15x plus 6. Subtracting those things would get you 0. Negative 17x because you're subtracting. Negative 2x minus 15x. And 6 minus 6 is 0, and so your remainder is a negative 17x. To find the slant asymptote, that really isn't that important. It is the quotient part, which should be the equation of a line. That's your slant. So your slant asymptote in this case is y equals x plus 3. Vertical asymptotes, you have to take the denominator and set it equal to 0 and figure out what the roots are. In this case, there are no factors of 2 that add up to 5, so you can't just factor it. So you would have to use the quadratic formula. Negative 5 plus and minus the square root of 5 squared minus 4 times 1 times 2 all over 2. And then when you simplify this, that is 25 minus 8. So a negative 5 plus and minus the square root of 17 over 2. If you want to figure out what the decimal form of those two things are, you could. Otherwise, you can just say the horizontal asymptotes are x equals a negative 5 plus the square root of 17 over 2 and negative 5 minus the square root of 17 over 2. Y-intercept, substitute 0 in for everything, for all the variables. So that's 0, so you have 6 on the numerator. That's 0, and that's 2 in the denominator, so 6 divided by 2 is 3. So 0, 3 is the y-intercept. Then for the roots, you don't have to worry about the denominator if it's just a rational function. All you have to do is take the numerator and set it equal to 0. So you have x cubed plus 8x squared plus 6 equals 0. And then you have to find the roots. Possible rational roots would be the factors of 6 over 1, and which should be 1, 2, 3, and 6, and I know none of those work. Both positives and negatives don't as far as those numbers. So in order to find them, you just want to graph this thing, just that part, and it will cross. I think it goes something like that. So then you just have to find that one root, and so then that would be your only root. And then one final thing with that, if you have a vertical asymptote, let's say it's not like with this problem. Let's say you get a vertical asymptote of x equals 3, and then you have another one of x equals 5. Well, if you find a root and it says x equals 3 also, that cannot be the case. So when there is a vertical asymptote that is also a root, that turns into a hole in your graph. And so then if you were looking at it graphically, at the coordinate of 3, it says it's a vertical asymptote, but it also says it's a root, which means the cross is right there, and that can't happen. So there's a hole. So if the graph were doing something like this, then it would have a little gap at 3 and then move on. You would not be able to see that little hole in it on your calculator, but you should know that when it's there and there is a hole. To enter this complete function into your calculator, you would want to put the numerator in parentheses and the denominator. So you would put x cubed plus 8x squared plus 6 divided by x squared plus 5x plus 2. And then you would see what the function looks like, which it kind of goes like this, and then this, and then this, I do believe. And this right here is x plus 3. There's an asymptote here, and there's an asymptote there. All right. Then doing these last problems here, if you're going to add complex numbers, you add the like terms. So that's 8 plus 3i. Subtracting 2 minus 6 is a negative 4, and 5 minus a negative 2 is plus 7i. And then here, 2 times 6 is 12, minus 4i, plus 30i minus 10i squared. And a minus 10i squared is the same as plus 10. And so then 12 plus 10 is 22 plus 26i. With this last one, if you're going to divide, it's 2 plus 5i over 6 minus 2i. And then you have to multiply by 6 plus 2i and 6 plus 2i. To do the multiplying, there's 12 plus 4i plus 30i plus 10i squared. In the denominator, it's 36 plus 12i minus 12i minus 4i squared. And so then 12 minus 10 is 2, and plus 34i, and 36 plus 4 is 40. And since all of those are divisible by 2, you could say 1 plus 17i all over 20. If they weren't all divisible by 2 or whatever, then you just have to leave it as that. Because when you divide, you have to multiply by a form of 1, which has to take on the same thing as the denominator, except you switch the sign in the middle. Finally, there's this, just dividing, and you would put negative 3 on the outside, a 1, an 8, a negative 7, and a 6 on the inside, and then go through the process. Add down, that's 1, multiply, that's a negative 3, then you have 5, multiply is a negative 15, that's a negative 22, positive 66, and then 72. And so your quotient would be x squared plus 5x minus 22 with a remainder of 72. Now the other thing that's significant about that is in this polynomial function, f of a negative 3 is equal to 72. Now, here are some other questions that I will go through in a second video if you want to look at these and try them. There's those 4 problems. Pause it. And then there's those 2. There are some other examples of things that could be on your test. And like I said, there will be a second video to cover just those things right there.